All right, in this video we're going to go over rotational kinematics, so just the basics of rotation. We've just studied torques, and what torques do is rotate things. So we want to understand how this this is really a special way that physicists measure rotation, not in degrees, but something called radians. Change this. So a radian is a rotation. Let's say a basketball is on a floor, and if it travels a distance equal to its radius, the basketball's radius, we say that it has rotated 1 radian, or an arc length of 1 radius. So if you've rotated 1 radian, how far have you rotated an arc length of 1 radius? So let's take a look at the picture on the right. It really says the same thing. So we're going to measure angles, degrees, in radians. Now, if a basketball rotates 1 full rotation, that's of course 360 degrees, but we say in radians it's rotated 2 pi radians. So 360 is 2 pi radians. 90 degrees, which is a quarter of 360, what's a quarter of 2 pi radians? Pi over 2 radians. So pi is really 180 degrees. Pi radians is 180 degrees because 2 pi radians is 360. So you'll find it'll become apparent why we don't use degrees with rotation, but we measure rotation in terms of radians, or really it's in terms of the radius of the circle. Let's take a look at this. Suppose the basketball rotated this much along the floor. It had a radius of 5, but it rolled along the floor 10. How many radians is that? Well, each time it rotates a radius, it's rotated a radians. So it's rotated 2 radiuses, or radii, so it's rotated 2 radians. Every time you cover a distance that's equal to your radius, you've gone a radian. So 10 is 2 radii, so you've gone 2 radians. So we say the rotation is 2 radians. So the basketball has rotated 2 radians if its radius is 5 and it's rotated along the floor a distance of 10 meters. We'll just make these meters and meters. So the equation is the distance that you travel, the radians is the distance you've traveled divided by r. In the example that we just did, it traveled 10 meters and my radius was 5. So how many radians? That's 2 radians. 10 divided by 2. So to get the number of radians, it's the distance that in rotating you've traveled, the distance you've traveled, or the arc length divided by the radius. So 2 radians if you traveled 10 meters when your radius is 5. Now if you cross multiply, you see the distance, or the number of radians, times r. I just simply cross multiplied the equation there. A wheel has a radius of 2, okay, r, rolls 5 meters along, that's your d. What's the number of radians? So the number of radians equals d over r, just the regular distance that you covered by rolling 5 meters. And your radius was 2. That was just given. So you've traveled 2.5 radians. So it's like how many radii did you travel? Let me make that 2.5 so you can see it. 2.5. So I've traveled 2.5 radians, or a distance that's equal to 2.5 times my radius. So that's radians. That's a way to measure rotation. So you've rotated 2.5. All right, so we know we measure rotation not in degrees but in radians. Well, when something is rolling, we measure the angular velocity in radians per second. That W is really not W, it's actually a Greek letter called omega. It's the lowercase omega. The uppercase actually is this, oddly enough. That's the uppercase omega, and that's the Greek omega. So you could write it like a curly W. All right, so let's relate the angular velocity to linear velocity. What's linear velocity? Just meters per second. It's what you're used to. I travel 10 meters in 2 seconds. My linear velocity is 5 meters per second. So a ball with a radius, there's r, rolls with a velocity v. What's its angular velocity? How many radians per second does it move? What's its angular rotational velocity? So here's how it works. Angular velocity, I already said, was w, curly w. It's radians per second, and the formula is the regular linear velocity divided by r, and so you cross multiply, and you can see linear velocity is omega times r, rotational velocity times r. So let's solve this problem. We just learned that angular velocity, that curly w, is just the regular linear velocity, which we're given over here, times r. So I can convert this linear velocity to angular velocity, or a rotational velocity, by dividing by r. The r is 0.5 meters, and it's, so 5 divided by 0.5 is 10 radians per, I ran out of room, so radians per second. That's how quickly it rotates. Let me put it over here, 10 radians per second. That is the how quickly it rotates. It rotates 10 radians per second. All right, now let's take a look at period. Now you're familiar with that. That's capital T. Define period. That's the time for one rotation. How long does it take for a basketball to rotate for one full rotation, which of course is 2 pi radians. So W, angular velocity, is 2 pi. There's one. You always do 2 pi radians, a full rotation in a period. So we cross, if you can take that equation, cross multiply, and you get omega times t is 2 pi radians, and so the period equals 2 pi radians over w, which is right there. But I like to just, actually, if I have a period question, I like to start with this, that when you go one full 2 pi radians, you're going to do that in a period. Period is defined for one full rotation, so I do one full rotation in a period, each period. So that's how I'll do any question about period with that, instead of this derived equation. All right, a ball with a radius of, here's my r, velocity, that's just linear velocity because it's meters per second. Find the period, that's capital T. So you know what I'm going to do instead? I don't really like this. I like to just go, okay, I'll start with this. Your angular velocity, well, first of all, actually, yeah, is I do 2 pi radians in one period, but now I have a problem. I don't have angular velocity, but maybe I can just use my brand new formula to get angular velocity. How quickly it rotate, it's W divided by linear velocity divided by r is W, so linear velocity is 5 meters per second divided by r, that's 0.5. We actually did that. That's 10.5 divided by 0.5 is 10 radians per second, and then I come right back over here, and I can find my period. So let's do this, 10 radians per second. So the first thing I did is I found W, 2 pi radians divided by t, and this cancels out. And so 10t equals 2 pi. 10t equals 2 pi, and 2 pi is about, let's say, 3.28, right? 2 pi. Now divide both sides by 10. The period is the period, divide both sides by 10. 6.28 is 0.628 seconds. With two significant digits, the period is 0.63 seconds. So what did I do? I have a question about period, and I know I really like to, rather than memorize this makes more sense to me, that the rotational velocity is always a full rotation, 2 pi radians divided by the period, which is the time for one full rotation. they've given me v, and I say, well, I can't use v. This equation doesn't have v in it, so I convert to angular velocity. And the way I do it, the way I take a linear and make it an angular velocity, how quickly is it rotating, I divide by r, and that becomes 10 radians per second. And now I bring it to my equation. The w is 10, the omega is 10 radians per second, and then I cross out the radians from both sides right here, and I cross multiply, get 10t is 2 pi, and divide both sides by 10, and there you go, there's the answer right there. Frequency is 1 over t. So what is frequency? The number of, let me clean up this mess over here first. Frequency is the number of cycles per second. Cycle, what's a cycle? It sounds like circle. It's the number of revolutions per second, where period is the number of seconds per cycle. Frequency is cycles per second. Cycle is a circle, a full rotation. So period is 1 over t. They're opposites of each other. They're inverse each other. So for the frequency above, that would be, if I just take 1 divided by 0.63 seconds, I get a frequency of 1.6 hertz. Okay, through repetition, you'll get there. This is actually, I think I've solved example 5 already. You've got this. Let me do this again. This will be valuable. I'm going to go over it again. Ready? You've got this radius. You've got this velocity. It's linear because it's meters per second. It's the old stuff. Find the frequency. I'm going to do it again. I know that what I know is frequency is 1 over period. So I'm going to do that period again for you. Ready? Omega, rotational velocity, is 1 full rotation divided by the period. This is linear, it's just v. So I can get angular by taking linear divided by r. So 5 meters per second divided by 0.5 meters. So my angular is 10 radians per second. And then it becomes a math problem. Now I'm going to find the period. I'm going to do it all over again just for your benefit. So we do cross multiply 10. The radians cancel out. 2 pi radians, I'm sorry. It's not 2 pi r. The 1 full rotation is 2 pi radians, so the radians cancel out. So 10t equals 2 pi equals 6.28, because that's what 2 pi is. T equals 0.6. I'm going to round it to 0.63 seconds. And the frequency is 1 over pi. And so it's turns out to be 1.6 hertz. So I did it again, just all over again, because, again, it's new. So let's look at the linear. This is linear motion to rotational. How do you convert? You should be able to convert. If you want linear, then all you do is take angular and multiply by r. If you want linear, take angular velocity, multiply by r, and then vice versa. Now, linear acceleration is r times what? That should be alpha. What's alpha? That's angular acceleration. So how do you go from, what if you have a linear acceleration? How do you get an angular? So now you learn that also angular is always equal to linear divided by r. You have to go both ways. How do you get linear? Multiply angular by r. How do you get linear velocity? Multiply angular velocity by r. How do you get linear acceleration? Multiply angular acceleration multiplied by r. So angular acceleration is the rate of change. The rate of change in acceleration. It's the rate of change in rotational velocity. How quickly is rotational velocity changing? So alpha is delta omega, which is rotational velocity, divided by t. So it's the rate at which angular velocity changes. So let's try a problem again. Pool ball with a radius. Now I think we're going with r equals 0.04 meters. convert it, goes from rest, which is VI equals 0, to VF equals 5 meters per second. And let me see, 1 second, that's t. Find the angular acceleration. So they give me all this linear stuff, meters per second, meters. What do? I know that angular acceleration is always linear divided by r. You always get angular by dividing by r. Let's review this again. How do you get angular rotation? Take linear divided by r. How do you get angular velocity? Take velocity and divide by r. That's always how you get your angular. So here's the thing. Listen to this. They've given me all linear stuff, so I just solve the problem. But they want angular. I'm going to solve this problem like it was a linear problem, and then at the very end, I'm going to convert. I could do it the other way. I could convert each one of these numbers to angular, but that's the harder way. Always solve, if you're given everything in linear, solve it as a linear problem, and then convert it to the end. What do I mean? What's a linear problem? A equals VF minus VI. This is like a first quarter problem. Let's find the angular velocity, then make it let's find the linear acceleration, then make it angular, which is really easy to do. So VF, 5 meters per second, and the initial was 0, divided by t is 0.1 seconds. So that's 50 meters per second squared. Now, I want to go, they really asked me for the angular, and that's alpha, by the way, in the Greek alphabet. So angular is linear divided by r. I have my angular is 50 meters, I have my linear meters per second divided by my r, which is 0.04 meters when I convert it into meters. And let's see what we get here. We get that my angular is, we need to do the division. So 50 divided by 0.04 equals radians per second squared. That's the unit for angular acceleration. It's radians per second squared. Okay, so you can see from here, whenever you want to get your angular units, simply take your linear and divide by r, which is the radius, is 0.04. I think we're going to stop right there. One last thing we have to do. Everything here, well, is it actually everything's here? This is in one significant digits, but you know what? Put a 0 next to that. Let's make this, what would we do to make this two significant digits? We go 1.3 times 10 to the third radians per second squared. Let's make that 0.0. Okay, and I think that'll do the trick.